yesterday. Today, if we know that process of distributing, it doesn't matter what type of problem we're given, we will still be able to figure out and simplify it. Okay, so today we're going to be looking at binomials, or maybe adding, multiplying a binomial times a polynomial. Oops. Oh dear. Try again.
By a polynomial?
Yeah. Okay, so what is a binomial? Two terms. What is a polynomial?
Any term.
Any number of terms, right? So it could be 2, it could be 3, it could be 100. All right, so let's say we have something like 2x plus 4 times 3x squared minus 7x plus 5. Now, the first thing my students think when they see a problem like this is, that's too hard. Yep, too much work. Nope, can't do it. Turn the page. Okay, but the reality is this actually requires zero new knowledge. In fact, I'm willing to wager that you all could tell me exactly what we should do to simplify this. What do we think?
You would...
Gabe, you have an idea? So let's start with that exact same process we started with yesterday. This is a binomial, so let's ignore 1 and start with the 2. And we're going to start distributing. And I already see your faces like, Mrs. McKinney, that is a lot of distributing. It is a lot of distributing, but it's not hard math work. Okay, so 2x times 3x squared is 6x to the third. 2x times a negative 7x gives us negative 14x squared. Two x times 5 gives us a 10x. Now what?
Now we distribute the 4.
Okay, so now go back and go here. 4 times 3x squared gives us 12x squared. So that 12x squared, where might it be helpful to write that?
Under the 14.
Under the 14x squared, so plus the 12x squared.
Oh, I'm done. What did that?
4 times a negative 7x gives us
Negative 28x.
negative 28x.
Did you do that in your head?
What? 4 times 5 gives us
20.
And now what do we think we should do? Add to combine the like terms. 6x to the third. Negative 14 and a positive 12 give us
Negative 2x squared.
negative 2x squared. 10 and a negative 28 give us a
Negative 18x.
negative 18x. Plus 20?
Plus 20. Yep.
I mean, so class, at this point, this could be a trinomial times a trinomial, and the process would still be the same. Distribute the first term to all of them. Distribute the second term to all of them. Distribute the third term to all of them. Right? It's just a bunch of distributing and then combining like terms, no matter how large the problem gets. Are we okay on that one? Then, the next 2 examples I want to look at, I'm pretty sure we're okay with because we hardly even batted an eye at it in the activity yesterday. But I just want to make sure 3 times 4x minus 3. Anything unique looking about this problem to start with? Right, they look exactly the same except for what? One's addition and one's subtraction. One's a positive and one's a negative. Okay, these get a really fancy math term that we call conjugates. You don't need to memorize that term. It is going to come up as we continue going throughout this school year. Okay, but conjugates is when they look the same, but one is addition and one is subtraction. Nothing changes about how we do this. Okay, so we're going to start this exactly the same, which means what are we going to do first? Distribute 4x. So 4x times 4x is 16x squared. Perfect. 4x times negative 3 is
12.
Negative 12x. All right, now we're going to start distributing the 3. 3 times 4x is
12x.
positive 12x.
So 16.
And 3 times negative 3 is?
Negative 9.
So 16x negative 9?
Yeah, so where did those 12x's go?
They canceled out.
Right, they canceled each other out. And we saw a problem just like this in the activity yesterday. I just didn't even say anything about it. Were there a couple of them? I didn't even say anything about it. Right, and you all just kind of like, okay, a couple of you said, you know, should I write something there? Should I not write something there? We were sort of figuring that out. But a negative 12 and a positive 12 becomes 0. And there's nothing to write down there. So we're just left with the 16x squared minus 9. Now, there are other situations where terms might cancel each other out, but it always happens with conjugates. So we'll always get that middle piece to sort of cancel itself out with conjugates. We okay on that one? Last one, and I would say that this is the most commonly missed problem. Oh, I don't even need a square here. Let's go here. 5x plus 3, all squared. I mean, there could be a square there. Students consistently miss this over and over and over and over and over and over. Even though when I ask them,
Oh, you just multiply the 2.
what is this problem asking us to do?
Multiply the number how many times?
Yeah, okay, so an exponent of 2 says to take, remember the fancy word for it is the base, to take the base and multiply it by itself the number of times of the exponent. So what do I need to multiply by itself?
5 times 5 plus 5. And 3 times 3.
Oh.
Why can I not, I mean, then my students say, but Mrs. McKinney, we just looked at these not that long ago, and how come then I was allowed to just put that exponent into each of the pieces?
Is it because it has an x in it?
Not because it has an x.
Just all of this word.
Yes, this has an operation in it. How many terms does this have? 2. All the problems we were looking at before were only one term. One term times one term is just multiplying a number times itself. Okay, but an operation, now we have to multiply that entire chunk by the entire chunk. And so this, I mean, now we just go back to the same process. 5x times 5x is 25x squared. Are we tired of distributing yet?
No.
We've been doing a lot of it. This tends to be one once my students learn, they do really like it because they can get pretty efficient at it. 5x times 3 is
15x.
15x.
Then 15x
3 times 5x.
plus 9.
25x
And then
squared
3
plus 30
times
plus
3.
30x. Plus 30x.
And you all don't even need me standing up here, you already have an answer.